This is the first video for polynomial function and rational functions. These are two pretty complex concepts, so we will touch some of the basic. Hopefully that will help. First, we will talk about polynomial function. So we have been doing several types of polynomial function, including linear functions, which normally it comes from y equal to mx plus b form as one type of linear functions. We have quadratic function that we just did, ax squared plus bx plus c. So if the highest power is x squared, then it's a quadratic, right? And a is positive would be open up parabola, a is negative would be open down parabola. They are all examples of polynomial function. So on your book, it will say this is the form of polynomial function, but even though if it's just like y equal to a number, that would be considered as a polynomial function. So basically, polynomial function have three major restrictions. For polynomial function, we cannot have negative exponents. We cannot have no fractions as exponents. And then we cannot have absolute values. So we are focusing on, when we talk about polynomial function, we want to look at the term with the highest power. Okay, so the term with the highest power, if we look at this example, the highest power is x to the 4th, so this is the highest power, so we call that the leading term. So leading term here, the whole term is positive 7x to the 4th, right? And the leading coefficient is the number attached to it, so it's going to be 7, positive 7. What degree is it? Degree is 4, so, and this considered as leading coefficient has a positive sign, so it's a positive a here. So those would be very significant when you need to decide how the graph is going to look like. So we will try some example in a little bit. So if we look at here, we need to be able to decide they are polynomial function or not. So we're focusing on the three restrictions, such as this one have the absolute value, right? So this is not a polynomial function because it has absolute values. And the next one, number 4, I can rewrite this as 6 times x plus 3. If it's in the denominator, it could turn into what kind of exponents? It can turn into a negative exponent. So also, this is not a polynomial because it has negative exponents. Okay, number 3, also I can rewrite the square root as this is 2 times x raised to 1/2 power minus 1. So because of that, we have a fraction exponent, so this is not a polynomial function. Okay. And number 1 and 2 are actually polynomial function, and they want to know what degree. So if I don't see x here, it means like this is x raised to 0 power, because x raised to 0 power equal to 1, right? And 1 times 7 is still 7. We didn't change anything. So this is, yes, a polynomial function with a degree of x is 0. And the next one, it has an invisible one here, right? So it's also a polynomial function with a degree 1. Alright, so this is just like some basic background information I want to show you real quick. If you need to watch this video to get like a better understanding or better grasp of it, like feel free to do it. The next page, we're going to look at the graph of polynomial function. So for the graph of polynomial function, let's see here. It need to be two things. It need to be smooth, and it need to be continuous. And it's kind of related to those three restrictions, because like if you have an absolute values, it kind of have a really sharp V like that, so it's not really smooth. If you have fraction exponents like x raised to 1/2 power, then it's like starting from positive numbers, so it's not continuous. What else do we have? And then no negative exponent. So if you have like this is y equal to square root of x, this is y equal to absolute value of x. If you have y equal to 1 over x, then it's going to come into pieces, so it's not going to be continuous. Alright, so look at these three graphs. The first one, is it smooth and continuous? Yes, so this is a polynomial function. The second one, it has some sharp corner, right? So it has sharp corner. So this is not smooth, so no, it's not a polynomial function. And the last one, it has an open circle here. So this is not a polynomial because it's not continuous. Okay, so the graph of polynomial need to be both smooth and continuous, and it's linked to the three restrictions we have, like no absolute values, no fractionless exponents, and no negative exponents, because like this one can be x raised to 1/2, this can be x raised to -1, right? Okay, so the next part is super important. Some of your homework question may ask you something like that. They want you to know the end behavior of polynomial functions, and it would be important when you take the business calculus. So I want you to think about the base graph that we have been talking about for both even and odd functions. So the one that we want you to remember is like y equal to x squared, y equal to -x squared. So we just did that the last chapter, right? So this one with the leading even power, for both of them, one is the leading coefficient is positive, one is leading coefficient is negative, right? So when your leading coefficient is positive with even leading power, it looked like an open up parabola, right? So this is both side up. And then if you have even leading power with leading coefficient a equal to negative, then you have an upside down parabola, which is both side down. So in general, if you have even leading power, depending on your leading coefficient is positive or negative, you're going to have both side up or both side down. This is depending on A is positive or A is negative. Okay, so this is very important. So if this is true, then you can figure out how is this end behavior going to look like. So this is leading even, A positive. So it's going to be both side up like the smiley face parabola, right? And this one is even leading power. With A is negative, it looks like an upside down sad face parabola, right? So one more piece of information that you need to know to finish the shape of the graph is the maximum turning point. So the maximum turning point, they call this n-1. So n-1 means it's going to be 1 less than the leading power. Okay, so looking at the one we just did. to the 4th power, so the leading power is 4, so the maximum term would be 1 less than that, right? So maximum term is going to be 4 minus 1 equal to 3. So if that's the case, I'm going to need to make 3 turns here. 1 turn, 2 turn, 3 turns. Alright, so this again is 4, right? 4 minus 1 is 3, so 1, 2, 3. So 1 look like a W, 1 look like an M, right? So that is for even leading power. So the next one would be the odd leading power. So we kind of talk about those also. For the odd leading power, x cubed is going to be the S curve look like this, right? This is when A is positive. And if A is negative, then you reflect it, right? So it's going to be flipped to the other side like that. So when you have odd leading power with A positive, it's going to be Y side up. This is both X and Y positive, right? Left side down. If A is negative, you flip. So when you have odd leading power, it's going to be one side up, one side down, and one side down, depending on your A value. So if I'm doing the 5th power, which is odd leading power, right? With A is positive, again, this side up, this side down, right? What is the maximum turns? The maximum term would be 5 minus 1 equal to 4, right? So that's kind of difficult to draw. 1 turn, 2 turns, 3 turns, 4 turns. So look like the back of a camel, right? So if A is negative, so you will flip it, right? So this side up, this side out. So you're gonna have 1 turn, 2 turn, 3 turn, 4 turns like that, right? So look like your camel just turn around. So this part of the end behavior is really important along with the maximum turn. So you kind of need to know that if you can see like I have so many stats, right? So this would be the part you probably want to review a little bit, maybe put it on index cards so you can look at it a few times. The next part, let's just try this. They say you have f of x equal to 3x to the 4, blah blah blah. So we don't really care about those, right? Because we just want the end behavior. So they're asking what is the end behavior. And also you probably want to be able to sketch the graph a little bit. So looking at that, remember we are focusing on the highest power term, which is the leading term and the leading coefficient, right? So looking at here, which one has the highest power? So the highest power is this guy. So what is the end behavior? So the leading term we have is going to be 3x to the 4th, which is like even leading power, right? With A is 3, which is positive. So and the maximum term is the degree minus 1, right? So degree minus 1 is 4 minus 1 equal to 3. So even leading A positive look like a smiley face parabola, right? So I started with my end behavior with both side up, and the maximum turn is 3, so I'm going to make 3 turns. 1, 2, 3. So it's going to look like a W. Are we okay with that? Okay, so one more piece of information. So this page is really important. So this one is like if the point is touching or crossing the graph. If x-intercept touching or crossing the graph. So if you come with an even power 0, it's going to be touching. If it's an odd power 0, it's going to be crossing. So I know it's kind of like abstract, right? Even power 0 is touching, and then odd power 0 is crossing the point. So let's look at a quick example. If we have f of x equal to x minus 1 squared, and then x plus 2 to the third power. So first of all, I want you to think about it's going to be a x squared times an x cubed, right? If you have x squared times an x cubed, what is the leading power? The leading power is going to be, you have 2 and 3 more, like same base multiplying, you add those exponents, right? So it's x to the 5th power, so it's an odd leading power. And then you have positive, positive, so A is going to be positive. So if you have an odd leading power with A positive, it's going to be like the odd leading positive like this guy, right? So one side up, one side down, and then the maximum turns with degree 5 is going to be 4, right? So 4 turns, 1, 2, 3, 4. So something like that. And then they go into a little bit deeper. So they say this one is going to be x minus 1 equal to 0, x equal to 1. This guy is x plus 2 equal to 0, x equal to negative 2. So sometimes people say you don't care about the power because if we have x minus 1 squared, mean x minus 1 times x minus 1. So you can solve them individually still equal to x equal to 1. It just happened 2 times basically. So you can kind of ignore that square in a minute. But this comes with an even power 0. So this means this particular part is even power 0. So this particular x equal to 1 intercept is going to be touching the point. And then this 3 represent odd power 0. Because of that, x equal to negative 2 is going to cause the point. So this would be significant when we graph it. So we just want you to have a little bit idea. So let's look at the next picture. The next example. Ready? Like anytime it is too fast and you want to pause the video and try to rewind that you're welcome to do that. Okay, let's look at these 2 pictures. So if I am looking at these 2 pictures and they say from the graph they want to know the minimum degree and whether the leading term is a positive or negative. So because it's both sides up, I know, and then this has 3 turns, right? 1, 2, 3 turns. So it has 3 turns. Remember the turn is 1 less than the degree, so the degree is going to be 1 plus 3 turns, which at least will be degree 4, right? So it's a degree 4, and then both sides up means even leading power. With the A is, leading coefficient is positive, otherwise it will be both side down, right? So you know those information just by looking at the graph, okay? And the next one side up, one side down, right? It means an odd leading power. With this side up, A is negative. How many turns? 1, 2, 3, 4. So if you have 4 turns, the degree is going to be 1 plus how many turns, right? So degree is going to be at least 5, and then one side up, one side down. With the left side up, it's going to be A is negative, okay? So just looking at the graph, we will be able to tell a little bit information of the polynomial function, okay? So the next 2 we're going to sketch like a little graph just to practice. And of course you can like grab it on the calculator, such as the first one. Like if it's college algebra, they will really focusing on you be able to graph it by hand. This one sometimes graphing by calculator is allowed because it's business math. So I have x minus 1 raised to the 2nd power times x plus 3, x plus 3. So again, I type y equal to and then just write that function, hit enter. You can hit graph over here, And if the graph doesn't show up really well on the picture, you can do zoom in, zoom out, or zoom fit, etc. So, and then you can trace some of the points sometime. So that's an option, but we kind of want you to have some idea how you do it on the on by hand too. So let's at least do A by hand. So it should look kind of like this, which makes sense, right? This is degree 2 and one more degree 3. X times X will be positive, so it's one side up, one side down. And because degree 3, so you have one less turn, right? So 2 turns. All right. Let's see. This one, we have x squared and then one more x, so x to the third degree 3 is going to be odd leading power. With A is positive, so maximum turn would be 3 minus 1 equal to 2. So I know my mini graph should look like this. All right, and here we can also try to find the x and y intercept. For x-intercept, we always set what? Y equal to 0. And for y-intercept, set x equal to 0. So if we set y equal to 0, it would be 0 equal to x minus 1 square, x plus 3. So x minus 1 equal to 0, x equal to 1. X plus 3 equal to 0, x equal to negative 3. All right, so we have the x-intercept. And this one comes with an even power 0. So it's going to be touching the graph, touching the points. And this has an invisible one here, right? So it's an odd power 0. So it's going to be causing the point. And then we have y-intercept. So y-intercept we set x equal to 0. So y equal to 0 minus 1 square. 0 plus 3, so it's negative 1 squared equal to positive 1 times 3 equal to a 3, right? So that's my y-intercept. Okay, so let's try to sketch it. So I know it's supposed to look like this, and then I need to cos y equal to 3 here, and then x equal to 1 here, and then y equal to negative 3 here. All right, so let's see. Sorry. So let's see, we have starting here, 1 supposed to be touching. So I get to this point, don't cause it, touch it, bounce back, and then cause my y-intercept, and this point is supposed to be causing, right? So when I get to this, I cause the point like this. So that would be my graph. That's how you graph by hand. Over here, let's see if you can do it by the calculator, because for your class is allowed. So let's see, if I have this, so I just quit over there, and I'm going to do y equal to, I'm going to clear what I have here. I need to put in x raised to the second power minus 4x minus a 5. So I know this is even leading power with a is positive, right? So even leading, a positive, the maximum turn is going to be 1 less than 2 equal to 1. So I know it's supposed to look like an open-up parabola like that, right? So we can graph it and double check. So it looked like this is correct. And looking at here, I have like x equal to negative 1 and x equal to 1, 2, 3, 4, 5, right? And also you can look at the table if you want to. Second graph is the table of those points, so you could also do that. So using that, I can sketch it. And some of the question on my lab asks you to use the calculator and make sure you know how to pick the correct one. So you have a 5 here, you have a -1 here, and then you can also look at what is the minimum point here. Okay, so this one just asks you to sketch, so I'm not going to be picky with that, but if we want to grab it by hand with all the details, we did it on the last section, finding the vertex, x and y intercept, etc. Right? Okay, so that part is going to be polynomial. The next would be rational function.